Nice little JCB handler, TM320S. Unfortunately, the headstock or bucket frame or whatever you want to call it is broken here and here. So the part I love most about these jobs is trying to analyse why these breaks have taken place, and things aren't as they first seem. These machines, as you can see, this link is absolutely ginormous, extremely strong link, and that means there's a monster ram up in there, huge bucket ram. Can't see where it's hiding, but very large diameter ram. What that means is the linkage is working very large range of movement, which means that the ram is working at a very low leverage ratio. So a low leverage ratio means you need a very large ram exerting a large amount of force, which is then divided down to much lesser force at the bucket tip. So you need a much bigger ram to give you a good workable operating force at the bucket edge, if you understand what I mean. So the linkage is working under extreme force and very small distances, very small leverage. So you imagine that those pin centers have to move a bucket blade probably right down about where the ground is. So the bucket has much more leverage over that little tiny amount of pin center distance. So it means all the steel and metal is under an incredible amount of force, and these cracks, they're still very strange. Like, I don't understand why this hasn't completely separated. You know, there's not much holding it. But even more strange is these cracks on the side of this very heavy block. And the only way those cracks there can take place is if that entire frame is flexing like that. That's because the bucket anchor points right here, the force is in there, and the pivot is here. So again, with that extremely long distance and all that weight there and the force in the middle, a block on each side, the force in the middle, it's bending that very heavy block, only bending it perhaps barely visible amount, say 2.25 of a millimeter, and over time that will open up these cracks. So yeah, I need to put a little plate on this, but that won't cure the original problem, which is this cross member not being strong enough, being rigid enough to resist the cracking. Whenever that bends up and down, it means these little plates will be bellowing, as I call it, and it's that bellowing over time that fatigues the metal, cracks it, and then breaks it. So I always find it very interesting to try and visualize the forces that are taking place on an almost invisible level. You know, the movement we're talking about is it's 0.0 millimeters. You know, it's very little movement, but over time that opens up cracks. So yeah, trying to visualize that's the part I find most interesting about the job, and trying to figure out how to minimize that movement, make sure the repair is permanent, is my favorite part. Get to exercise the old grey matter a little bit. And of course, it's not just as easy as slapping on a plate, because you've got clearance issues, everything's very, very tightly constructed, so there's not always room just to slap a big lump of metal on to strengthen it up. So yeah, it's a good one. So I have to assess what I can do. The worst problem, most of all, this is why I'm going to be quick, is the owner needs it back to feed his animals this evening. So the balls are to the wall today. So I'm going to have to stop the chit chat and actually get ripped into it. So I think first of all I'm going to take it off in order to do the job that I want to do. Try and get a strong weld. Gouging in the side here is going to be less than ideal. I won't be able to get on the inside crack, so I'm going to take it off, stand it on its edge, gouge these on the flat, weld them on the flat. That means we've got the best weld we can have. Gouge and weld all these little cracks afterwards will be the easy part, and then we'll assess what plates we're going to put onto it. But yeah, as I said, the owner wants it back this evening to feed the cows. The poor cows are going to go hungry, and you're not going to have milk to put in your cornflakes tomorrow. So yeah, we better get at it. Anyway, stay tuned, folks. So that's it off. Get a better view of the cracks now. I get better space to repair them. So yeah, I think we'll fire the gouger up, V them out, full penetration, both sides, weld them up, and that'll be the cracks repaired, and then we'll assess how we're going to add strength. So yeah. So I've roughly drawn out the little strengthening plate that I want to put on. Restricted by thickness, so I'm going to use a high tensile plate, good old Hardox 400, and probably only 6mm, but 6mm as percentage of this thickness should near enough double the strength of that area. So yeah, the profiler guy, he has templated this shape, and he's up on the profiler at the moment, drawing it out, cutting the plate out. Meantime, I'm going to gouge out these cracks and prepare them for welding. The crack is a little bit open, as you can see, which isn't a massive concern. Doesn't really justify the time and effort required to close it, for all the displacement that it will leave. Just means the bucket will be in a slightly different position, but only by a degree or so. It'll be virtually unnoticeable, so it's not even worth the effort of going to try and get that gap closed. So we'll gouge it out and weld it up solid. So that's all of the cracks gouged out. Gouge these from one side, we'll fill them up with weld. Then we gouge out from the other side into the back of the good weld. That means any impurities in the bottom of the prop will be removed whenever you back gouge them. So it's imperative that the track is as clean as possible before welding. So that's it, basically fully prepped. All the cracks removed. Time to put the weld back. In the meantime, our plastic guys just came back with a nice little plate. Looks very thin and flimsy, but as I said, this is a high tensile, very strong material. Hardex 400. I'll try and look up some specifications on it for you. Although it's only 6mm thick, the rule of thumb is that it's 3 times stronger than mild steel, so that's equivalent of putting 18mm normal steel plate on there. So we'll give a massive increase in strength in this restricted space area, and a nice run of weld around the outside of it. Single pass will do the job. Because it's a higher strength material, yes, you should be welding it with a suitable filler. I'll just be welding it with mild steel because the circumference of the outside is much greater than the narrow part in the middle, so all of this weld around the outside will be more than enough to hold this narrow piece in the middle. So yeah, you always get the welding professors in the comments trying to tell you, oh, you're using the wrong filler. No, I've considered it, and normal 70 series mild steel wire will be sufficient. Love learning metallurgy. I don't know very much about it. I'd love to get some books and read up on it. It's just an absolutely incredible topic, very detailed, and a complete field of knowledge on its own. So having a little snippet of metallurgy knowledge is very useful when welding. I could do with an awful lot more, and I love learning new things every day. So yeah, I reckon that will give us a significant enough increase in strength. I need to be careful not bring that too close to the hole, or it'll simply break here. So we'll keep it back off the hole a little bit, and keep it away from this corner, feather it off here, try and dissipate the stresses. But that should be more than adequate. So yeah, let's get her welded on there. We'll give it a little preheat first. That should be good to go. It's pretty hot from gouging, so I'm going to get straight into those cracks. So just repositioning this on, I don't know if you can see that, but yeah, I was right on the money. You can see the frame, it's curved. Exactly what I was saying about it bending. So yeah, that's what was causing all the cracks down the outside of the weld. I knew it was because it was specifically on the outside of the weld and not on the weaker piece, which would have been this. That's how I knew that it was this that was moving. So yeah, that's 1/2 welded. Both sides, so We'll air down on the flat, do all those cracks, turn it over gouger and finish the welding on the other side. So that's all of the cracks welded up on the base, and the little strengthening plate put on one side. You can see the weld repair going halfway through. So as I said, now I'll gouge from the other side into the back of that weld it up solid. So yeah, we're making good progress. I'm fairly confident I'll have this finished this afternoon. So yeah, we'll flip it over, do the other side. Hopefully these lugs won't have spread too much. When you put welding on one side, it will pull it over, but try and counteract it with weld on the inside, and it should be roughly where it started. If not, we can always heat line a little. I'm hopeful just with the age of the machine there'll be enough clearance on this pinhole for the pin to enter without any issue. In fact, I'll just do a little test now. There we go. No issues at all. So yeah, we'll come back after the lunch break. Get her finished off. So that's it turned over, and we're going to gouge out the back of the cracks now. Weld on the strengthening plate on the top, and that's it, ready to go. So that's the back of the weld gouged out. On the other side of the crack, I'll grind those up, clean all the snotters off. A little extra crack there. Clean it all up, weld it up, stick the strengthening plate on, and that will be it, ready for assembly. So that's it, fully welded. Very happy with that. The end sealed up. Both sides, strengthening plate on the outside, all the cracks done. So time to assemble it, cycle it through its range of movement, and do a little clearance check and send her on her way. So yeah, we'll get her back in and get it pin down. So that's it, fully assembled. All we have to do now is run a little test to make sure that this plate is going to clear this. If not, we'll just have to knock a bit off the corner with a grinder. So we'll start her up, try her through her operating cycle, and see if it clears. So yeah. Delighted with that, it's all clear. That's her, job done. The only thing I wanted to do was add strength across this block, but unfortunately we don't have time, so I have to investigate that another time, see if we can put a massive bar underneath. It's the only place that we can add material and strength to it. But he's got to get her home and get the cows fed, so at least it's repaired anyway. Lovely little machine. So yeah guys, hope you enjoyed that video. If you did, give me a thumbs up and a share and a like and all that jazz. Greatly appreciate it. I keep making these videos for you guys, but it all depends on that little thumbs up. It makes all the difference. Very much appreciated guys. Check out my other videos, a few more repairs and welding and stuff, and some fun off-road action, and what else have we got, some tractor action and engineering. I like variety on my channel. There'll be a lot of different videos, so please don't unsubscribe if you get a video you don't like. I will have some variety, but just hang on. If you like the welding, there'll be more welding videos. If you like diggers, there'll be more digger videos. If you like off-roading, there'll be more off-roading videos. So yeah guys, hang around, don't go anywhere, please don't leave me. Anyway guys, thanks very much for watching this video, and I'll see you on the next one. Cheers guys.